Okay. Hello, everyone, and happy Walking Wednesday. We are actually going to get started right away because we are covering the endocrine system today, and we have a lot to cover. So, just a reminder for anyone who's new here, our Walking Wednesdays are a workshop where you can get up and move your body while I lecture you, basically. Um, the point of it is that we can learn about health and wellness topics picked by you um, together while you guys are getting some movement in. So, whether that be walking around your office or doing some marches at your desk or some stretches, whatever it may be, the goal is for you to get some movement during this next 30 minutes. Like I said, our workshop today is going to focus on the endocrine system. For the month of August, we are focusing on loving your organs. We recognize that there's a lot of organs in our body, and a lot of us have not learned beyond basic biology or anatomy from high school about each of our organs, and yet it affects everything in our life. And especially as we age and things start becoming struggles and problems, we really want to just dive into some of these organs and systems this month that we're not as familiar with. And so this month, for this workshop, we're going to be focusing on the endocrine system, which is an incredible system that uses both organs and glands. And throughout our lives, we experience illness, hormonal shifts, disease, and all the natural changes that come with aging. And so we are going to see how this affects each of those. So like I said, the endocrine system is made up of glands and organs that communicate through hormones. These chemical messengers regulate vital functions like growth, metabolism, mood, and together, when they're working properly, the endocrine system helps keep the body in balance. There are 9 key structures in this system. So there's the hypothalamus, the pituitary gland, the pineal gland, the thyroid gland, parathyroid glands, the thymus, adrenal glands, pancreas, and ovaries or testes. And we are going to dive into each one of them and focus on what hormones they each release and how that affects our bodies. So we're going to start up at the top, which is your hypothalamus. The hypothalamus is located deep within the brain, and it acts as the control center of the entire endocrine system. It tells the pituitary gland what to do, which in turn influences the activity of the other glands in the body. The hypothalamus produces 2 types of hormone. They're releasing and inhibiting hormones to regulate various processes. So the first one we're going to talk about is TRH, which is thyrotropin releasing hormone, and it signals the pituitary to release TSH, which is thyroid stimulating hormone, and that regulates our metabolism, energy levels, and body temperature. The next one is corticotropin releasing hormone, which is released in response to stress or low blood sugar, and it helps regulate inflammation, blood pressure, blood sugar, and the body's overall stress response. Then we have gonadotropin releasing hormone, which stimulates the release of luteinizing hormone, and follicle stimulating hormone, which controls puberty, menstrual cycles, fertility, and reproductive health. There's the growth hormone releasing, which promotes growth, cell repair, and development of muscle and bones. We have the growth hormone inhibiting hormone, which prevents excessive growth and regulates thyroid level hormones. And then we have the prolactin inhibiting hormone, which suppresses the release of prolactin to prevent milk production unless it's needed after childbirth. So together, these hormones help the body respond to changes, manage stress, and maintain stability. As we explore more of the endocrine system, you'll see just how interconnected our bodies truly are. And so with that, the next gland that's up is the pituitary gland. This is often called the master gland of the endocrine system. It's a tiny pea-sized gland. It sits at the base of the brain, just below the hypothalamus, and it plays a really big role in regulating the body's hormonal functions. It's directly connected to the hypothalamus, which is where, as we saw, that's where the hypothalamus sends instructions to the pituitary gland, and then the pituitary gland sends its instructions via the hormones. So there's two main parts of the pituitary gland. There's the anterior pituitary, which is your front lobe, and this produces and releases 6 key hormones, each targeting very specific hormone or very specific organs. So there's your growth hormone, which stimulates growth, cell repair, and metabolism, and it targets the muscles, liver, and bones. We have our thyroid stimulating hormone, which stimulates the thyroid gland to release T3 and T4, which regulate metabolism. We have the adrenocorticotropic hormone, which stimulates the adrenal cortex to release cortisol, which is the body's primary stress hormone. We have our follicle stimulating hormone, which promotes egg production in ovaries and sperm production in the testes. We have luteinizing hormone, which triggers ovulation in females and stimulates testosterone production in males. And then we have prolactin, which stimulates milk production in the mammary glands after childbirth. So a lot of these might sound really familiar because we just talked about a lot of the ones that tell the pituitary gland to release these in the hypothalamus. So all of those 6 hormones, those were released by the anterior pituitary gland. This is a mouthful in case anyone's wondering. Okay, posterior pituitary, which is the back lobe of your pituitary gland, does not produce any of its own hormones. Instead, it stores and releases 2 hormones made by the hypothalamus. And these are your so this is oxytocin, which targets the uterus, breasts, and brain. It causes uterine contractions during labor, promotes milk release during breastfeeding, and fosters emotional bonding. And then vasopressin, which targets the kidneys to regulate their water balance, reduce urine output, and raise blood pressure when necessary. So the pituitary gland in total is essential for growth and development, fertility, metabolism, regulation, stress response, and fluid balance. So when it's not functioning properly, either producing too much or too little of a hormone, it can lead to serious health issues such as gigantism, hypothyroidism, infertility, Cushing's disease, and even some forms of diabetes. And we'll talk more about how to support and maintain a healthy endocrine system at the end of the workshop. But understanding that the pituitary gland is the master gland is our first critical step in understanding how the whole system works. So after the pituitary gland, we have the pineal gland, one of the smallest but most fascinating glands in the body. It's located deep in the center of the brain between the 2 hemispheres in a groove where the 2 halves of the thalamus join. The pineal gland plays a key role in regulating your sleep-wake cycle, also known as your circadian rhythm. And the pineal gland's primary function is to produce and release melatonin. That's the hormone that signals your body when it's time to rest. As daylight fades and it becomes dark, the pineal gland increases melatonin production, helping you feel sleepy and preparing your body for sleep. In the morning, when the light is detected through the eyes, your melatonin levels decrease, allowing you to wake up and feel alert. So although very small, about the size of a grain of rice, the pineal gland is vital for maintaining a healthy sleep pattern, and disruptions in melatonin production, such as excessive screen time at night or jet lag or shift work, can lead to insomnia, fatigue, and other sleep disorders. Some researchers also believe that the pineal gland may influence mood, immune function, and reproductive hormones, although those areas are still being studied. Okay, next one. Let's talk about the thyroid gland, which is easily probably one of the most talked about glands, and for a good reason. The thyroid is a small butterfly-shaped gland located in the front of your neck, just below the Adam's apple. And despite its small size, the thyroid plays a massive role in regulating your metabolism, which is essentially how your body converts food into energy. But metabolism isn't just about burning calories, but it impacts nearly every system in your body, including how fast your heart beats, how warm you feel, how quickly your brain processes information, and even how your body grows and heals. The thyroid produces two primary hormones, thyroxine, known as T4, or triiodothyronine, which is T3. While T4 is the most abundant thyroid hormone, it's relatively inactive on its own. Once it enters cells, it's converted into T3, the more active form of the hormone that directly affects how your cells function. These hormones are made using iodine, which is why iodine, found in iodized salt, seafood, and seaweed, is essential to the diet. The production and release of T3 and T4 are regulated by the thyroid stimulating hormone, which is released once again by that anterior pituitary gland in response to the signals from the hypothalamus via TRH. It's a very delicate feedback loop that keeps your body in balance. So what does T3 and T4 actually do? Well, it impacts pretty much every organ system in the body. First, by increasing your basal metabolic rate, which determine how much energy your body uses at rest, which influences weight, energy levels, and temperature regulation. And then two, by regulating your heart rate. So T3 and T4 both help the heart beat faster and stronger, which support blood flow and oxygen delivery to tissues. And then the third one is enhancing brain function. So adequate thyroid hormone levels are crucial for memory, concentration, and mood regulation. They also affect growth and development, especially in children. Thyroid hormones are essential for normal bone growth and brain development. T3 and T4 help maintain body temperature. They increase heat production in your cells, helping you stay warm. And last but not least, they also help support your reproductive health, and imbalances can lead to irregular menstrual cycles or fertility issues. So why does it matter? Well, when the thyroid is overactive, called hyperthyroidism, meaning it makes too much T3 and T4, this can cause symptoms like rapid heartbeat, anxiety, weight loss, heat intolerance, and difficulty sleeping. When the thyroid is underactive, it doesn't produce enough hormones. It can lead to fatigue, weight gain, depression, cold sensitivity, a slowed heart rate, and slowed thinking. Even small imbalances in thyroid hormone levels can impact how you feel on a daily basis, which is why thyroid health is so important and why so many people are talking about it. So after that, let's pivot to the parathyroid glands, which are the small but mighty regulators of your body's calcium levels. Despite their name, the parathyroid glands are not part of the thyroid gland. Instead, they consist of 4 tiny glands located on the backside of the thyroid in the neck. Each one is about the size of a grain of rice, but together they play a critical role in your health. The parathyroid glands produce a single essential hormone called the parathyroid hormone. Doctors get really creative in their names. But the parathyroid hormone is a key regulator of calcium, phosphorus, and magnesium levels in the blood and bones. Its main job is to maintain stable blood calcium levels, which is vital because calcium does so much more than just support your bones. When calcium levels drop too low, the parathyroid glands release the PTH to bring them back into balance, which stimulates the release of calcium from bones into the bloodstream, increases your calcium absorption in the intestines by activating vitamin D, reducing calcium loss through the kidneys so that more is retained in the body. So calcium is essential not just for strong bones and teeth, but also for proper nerve function. Calcium allows nerves to send signals efficiently. It allows for muscle contractions, including the heart, which relies on calcium to beat. Your blood clotting, without calcium, your blood wouldn't clot normally. And then hormone and enzyme release. Many cellular functions require calcium as the signaling molecule. So even small imbalances in calcium can lead to serious health complications. If calcium is too low, hypocalcemia, it can cause muscle cramps, tingling, numbness, and even seizures. Or if it's too high, hypercalcemia, symptoms can include fatigue, kidney stones, confusion, and weakened bones. So once again, parathyroid may be small, but their job is very, very vital. Okay, so next up is the thymus, which is often an overlooked gland, but it plays a vital role in our immune system. So the thymus is located in the upper chest, just behind the breastbone and in front of the heart. It's most active during childhood and adolescence when the immune system is still developing. And as we age, the thymus gradually shrinks and becomes less active, a process called thymic involution. But its early work has long-lasting effects on our immune response. So the thymus produces a hormone called thymosin, which is essential for the development of it's essential for the development and maturation of T cells or T lymphocytes, a specific type of white blood cell that defends the body against infections and abnormal cells. T cells are like the soldiers and strategists of your immune system. They are produced in the bone marrow, but mature in the thymus, where they learn to distinguish between your body's own healthy cells and harmful invaders like bacteria, viruses, and even cancer cells. There are several types of T cells, each with a different job. So you have your helper T cells, which coordinate the immune response by signaling other immune cells to act. You have your cytotoxic T cells, which directly attack and destroy infected or cancerous cells. You have your regulatory T cells, which prevent autoimmune response by ensuring the immune system doesn't attack the body's own tissues. And then you have your memory T cells, which remember past infections and help the body respond faster if the same pathogen returns. So without proper T cell development, the immune system can become weakened or dysfunctional, leading to increased risks of infection or autoimmune diseases. So once again, the thymus is most active during early life when the immune system is still learning how to respond to threats. This is why thymosin and the thymus gland are especially crucial in infants and young children. And then by adulthood, most of your T cells have matured and the thymus slowly shrinks and is replaced by fatty tissue. But even though the thymus becomes less active over time, its early role in training the immune system is what allows it to continue functioning properly throughout your life. So while it may not get as much attention as other glands, it's absolutely essential to a healthy immune system. And supporting the development of T cells lays the foundation for your body's ability to fight infections, protect against disease, and maintain immune balance. Whew. Okay. Next up on our endocrine tour are the adrenal glands. These are your body's built-in stress responders and energy regulators. The adrenal gland are two small triangular-shaped glands that sit like caps on top of each of the kidneys. But despite their small size, they produce some of the most powerful hormones in the body, especially during times of stress, danger, or physical exertion. Each adrenal gland is made up of two distinct parts that have different functions. So we have our adrenal cortex, which is the outer layer, and this part produces hormones involved in long-term stress response, metabolism, and electrolyte balance. So cortisol, the stress hormone, is what helps our bodies cope with prolonged stress, whether physical, emotional, or environmental. It increases blood sugar level to fuel your muscle and brain. It regulates inflammation, helps with blood pressure control, and even affects mood and memory. However, too much cortisol over time, such as during chronic stress, can lead to fatigue, weight gain, weakened immunity, and other health issues. The adrenal cortex also produces aldosterone, which helps regulate your body's sodium or salt and water balance, which directly affects your blood pressure. It signals the kidneys to retain sodium and release potassium, which helps maintain proper fluid levels and keeps your blood pressure stable. Without aldosterone, your body could quickly become dehydrated and experience dangerously low levels or low blood pressure. The second part of the adrenal glands is the adrenal medulla, which is the inner core. And this part produces hormones that respond to immediate stress, commonly known as the fight or flight response. So it produces adrenaline, also called epinephrine. Adrenaline is released during sudden stress or emergencies, and it increases the heart rate, breathing rate, blood flow to muscle, and alertness, all to prepare the body for quick action. It also releases stored glucose into the bloodstream for a rapid burst of energy. And without adrenaline, we wouldn't be able to respond quickly to danger or high stress situation. And so the adrenal glands work very closely with the hypothalamus and the pituitary gland in what's called the HPA axis to maintain homeostasis and respond to both short-term and long-term stresses. The hormones produced in the adrenal glands are essential for survival and responding to danger, regulating metabolism and energy levels, balancing fluid and electrolyte levels, controlling inflammation and immune function, managing blood pressure and heart function, and coping with emotional and physical stress. And if the adrenals aren't functioning properly, it can lead to conditions such as Addison's disease, where the adrenal glands don't produce enough cortisol or aldosterone, leading to fatigue, low blood pressure, and electrolyte imbalances. This is also where the Cushing syndrome comes into play, where too much cortisol is produced, often leading to weight gain, high blood pressure, and a weakened immune system. And then there's adrenal fatigue, which is a very controversial topic right now. So though it's not officially recognized as a medical condition, some believe chronic stress may impair adrenal function over time. So the adrenal glands are your body's emergency response system and the long-term energy managers. So when you're running from danger or managing everyday stress, we need our adrenal glands to be working so that we can keep up with life demands. Okay, only 3 more organs to go. Don't give up on me yet. So next up is the pancreas, which is a unique organ because it plays a dual role in both the endocrine system and the digestive system. So the pancreas is located in the upper abdomen, tucked behind the stomach. And while it's often recognized for its role in digestion, it also plays a critical role in regulating your body's blood sugar levels, which is vital for energy and overall health. The endocrine portion of the pancreas is made up of a cluster of cells called the islet of Langerhans. These tiny clusters are where important hormones are produced and released directly into the bloodstream. 2 of the most important hormones are insulin, which is produced by beta cells, and insulin is what lowers blood sugars by helping glucose move from the bloodstream into cells where it can be used for energy or stored for later use. After you eat, your blood sugar naturally rises, and insulin is released to help bring it back down to a safe range. The pancreas also produces glucagon, which is produced by alpha cells. Glucagon does the opposite of insulin. When blood sugars drop too low, like in between meals or during physical activity, glucagon signals the liver to break down stored glycogen into glucose and release it into the bloodstream, and which raises your blood sugar to help you keep your energy levels stable. Together, insulin and glucagon work like a thermostat, constantly adjusting your blood sugar to stay within a healthy range. And this balance is crucial because both high and low blood sugar can be dangerous. When the pancreas is functioning properly, you hardly notice it. But when things go wrong, the effects can be very serious. So 1 is type 1 diabetes, which is an autoimmune condition where the body attacks beta cells and the pancreas stops producing insulin. People with type 1 diabetes must take insulin to survive. And this is something that cannot be treated by lifestyle. Type 1, like it says, is an autoimmune condition. And then type 2 diabetes is a condition where the body becomes resistant to insulin or doesn't produce enough. And this often develops over time and can be managed with lifestyle changes, medication, or insulin, depending on severity. And then hypoglycemia occurs when blood sugar drops too low and is often due to excess insulin or not enough food intake. So, conclusion for the pancreas is that it's a powerful multitasker that supports digestion and ensures your cells get the energy they need through careful blood sugar. Control. It releases insulin and glucagon and keeps your body fueled and functioning. Okay, we made it to the final two organs, the reproductive glands. So we're going to first start with the ovaries. So the ovaries are your two small almond-shaped organs located in the lower abdomen on either side of the uterus. They are primary reproductive organs in the individuals assigned female at birth, and they serve two key functions. One is producing and releasing eggs for potential fertilization, and two, producing essential hormones that regulate menstrual cycle, pregnancy, and many other aspects of health. The two primary hormones produced in the ovaries are your estrogen and progesterone, although they also do produce testosterone. These hormones don't just impact reproduction, but almost every organ system in the body. Estrogen is often considered the captain of the hormones in the biological female body because of its wide-reaching effects. It's actually a group of hormones, including estradiol, estriol, and estrone, which plays roles far beyond fertility. But for the most part, estrogen regulates the menstrual cycle, supports pregnancy, helps develop secondary sex characteristics, affect mood and brain function, supports bone density, and protects the cardiovascular system. It also influences skin, hair, and fat distribution. Oh, I lost my place. Okay, so why do the ovaries matter? Because they are central to fertility as well as to the function of the brain, bone, heart, metabolism, immune system, and emotional health, which is why major hormonal changes like those during menopause, those who struggle with PCOS and ovarian insufficiency can lead to a wide range of symptoms such as fatigue, mood changes, weight fluctuations, hot flashes, and so much more. And then the final organ that we're going to talk about is the testes, which are the two oval-shaped organs located in the scrotum. While they are best known as the male reproductive organs that produce sperm, the testes are also primarily responsible for producing the hormone testosterone. Testosterone is the primary male sex hormone, but it's also an essential hormone for many functions, once again, beyond reproduction. The testosterone is produced by specialized cells called the Leydig cells, which are stimulated by the luteinizing hormone from the anterior pituitary gland. And it plays a vital role in the development of male reproductive organs, secondary sex characteristics, reproductive function, as well as supporting red blood cell production in the bone marrow. And it has the same struggle. So when testosterone is low, it can lead to fatigue, decreased energy, low libido, depression or irritability, loss of muscle mass and bone density, and increased body fat, especially around the abdomen. So both the testes and the ovaries are both key players in reproduction as well as hormone regulation. Okay, we've got 2 minutes left, and I don't want to end the workshop without talking about a couple things that we can do to help maintain the endocrine system and keep it healthy. As always, the best place to start when we're looking at ways to maintain our endocrine system's health is food. So we want to make sure that we're getting a variety of foods, lots of fruit, fresh vegetables with lots of different colors mixed in there. Whole grains, lean proteins, and healthy fats will all give our hormones the materials they need to function properly. We also want to make sure that we're getting in those omega-3s specifically because those really help with hormone production and they help keep our inflammation in check. And so you can find omega-3s in things like salmon, sardines, flaxseed, chia seeds, and walnuts. And then hydration is key. Utah is a very dry state. We want to make sure that we are giving our bodies the proper blood flow it needs and the nutrient transport in order to support those hormones. And water is the delivery service. So we need to make sure that we are staying hydrated. Next up is we want to balance our blood sugar, which is not as hard as you think. We just need to pair our proteins and healthy fats with a carb so our energy stays steady and our adrenal glands don't have to work overtime. And then our micronutrients matter. Specifically for the thyroid, we really want to make sure that we have enough iodine in our system. So whether that's through seaweed or seafood or even iodized salt, we want to make sure that our levels are strong there, as well as selenium. Selenium works as your thyroid's bodyguard, and it helps to produce hormones and protect against damage. So the best source of selenium is actually in Brazil nuts. Just 1 or 2 Brazil nuts a day is plenty. It's also found in things like eggs and tuna. And then last but not least, we want to try and cut down on hormone stressors. So limiting processed foods, excess sugar, and too much caffeine, all those can throw our hormone balances out of sync and cause stress on our bodies. So bottom line, your endocrine system isn't just asking for a perfect diet. It's just asking for some consistency and some recognition for all that it does. Think of fueling a high performance car. When you give it the good stuff regularly, it'll run smoothly for years to come. And that's what we want to do for our endocrine system. Okay, that's all I have. I threw a lot at you. Feel free to throw some questions in the chat. And then as always, on your screen is a QR code that you can scan in order to ask your questions. And those are the questions we try to answer each month in our walking workshop. But other than that, that's all I've got. Thank you guys so much.